I am really excited about this video because I am not joking when I tell you that algebra is actually very simple. And it doesn't matter if in school you found it boring, you found it confusing, or just straight up hated it. Today we're going to fix that. I'm going to take you step by step from the absolute basics to solving problems you never thought you could touch. And here's the thing, every part builds on the last. So if you stick with me to the end, you're going to see your skills level up in ways you didn't think was possible. And trust me, you will leave this lesson with a whole new level of confidence. So let's go, let's get started. We're going to start with this very important question. What is algebra? And in this instance, we are going to define algebra as simply maths with letters. And these letters, they represent variables. And these variables are basically our unknown values that we're trying to find. And in this example, which I'm using this equation to give us the example, we have x plus 5 equals 9. And in this instance, of course, we have x as our variable or our unknown. And we're trying to find out what x is. So that's the first thing. We know that we have variables, and we're going to look at other terms that we need to be very, very aware of, because as I said, we're going to build this up and gradually get to different levels of difficulties. Now in algebra, we have these things called expressions. Now a more accurate term would be algebraic expressions. So algebraic expressions, now what are they? It's made up of what we call terms, and I'm going to define that for you now. So let's say we have 5x and 5x plus 3. Now in this instance, we have a total of two terms, and I'm going to define what terms are. So in this instance, we have 5x as one term and we have 3 as another term. And the terms in this case, they are just separated with either a plus or a minus. And we have that numerical value, which is a special type of term. It's called a constant term. And we have that 5x, which is another term. And this one, we've talked about variable before. So this one is a variable term. So that's two types of terms that we have. And within the variable term, we have another terminology that we need to be aware of. And it's the 5, and the 5, which is the number there that's been used to multiply by x, that's what we call the coefficient. So that's coefficient. And those are some of the basic terminologies that we need to be aware of. Now, we also have this thing called like terms. Now, like terms are simply terms that have the same variable raised to the same power. Let me show you what that means now. So let's say we have here 3x plus 4x. Now, because we have x in both of these terms, then they are classed as like terms, and we can simply add these two together to get 7 x's. It's just as if we're adding 3 apples with 4 apples. We have a total of 7 apples. It's literally the same thing. Now, in order for terms to be like terms, of course, it's not just x we have. Let's say, for instance, it was 3x squared plus, let's say, 4x. This is where raised to the same power comes in, because this one is 3x to the power of 2, whereas this one, the power technically there is 1. So these two, they have different powers, so it means that they are unlike terms. And what that means here is x squared is the same as having 3 times x, and that's for the x squared, whereas the 4x is just 4 times x. So it means then that these two, one of them got a multiple of x's, whereas this one doesn't. So these two are unlike terms. Now, it's not just x's we have. If we had, let's say, 3x, let's say we had 3x plus 4y, because these are different letters, then there will be unlike terms as well. And with that, we're going to get into the first sort of algebraic type calculation. And let's do that now. So this is us simplifying expressions. So let's say we have 2x plus 5x and minus 1. So just as the example I've used with the apples, what we're having here is 2 lots of x's plus another 5 lots of x, and I meant to have minus x right here at the end just for simplicity to begin with. So in this instance, 2x plus 5x minus x. So let's see, we can simplify this to say we have 2x plus 5x, so that's 7x's, and minus that x there leaves us with 6x's, and this would be the total amount that we have left. And you can also write this out like so you can just do the 2 plus 5 minus 1x, and you just simplify here. So we'll have 2 plus 5 and minus 1, and that leaves us with 6 lots of x's. Now let's look at another example where we have unlike terms. So let's say what we had here was 3a, and that's been added with 2b minus 5a and plus 4b. So in this instance, you have to identify all your a's. So what we have here, we have 3a, and we have to see this as a minus 5a. So I'm just boxing that up. And then we have plus 3b here and plus 4b. I know that it looks colorful now, but it's just for us to be able to group them properly. So let's group them up. So let's say we have now that 3a, and this is minus 5a that we're going to put there. So we're just putting the a's together. So that's minus 5a. And then we have this plus 2b now. So plus 2b, and that next there plus 4b. And of course, when we simplify this, we get that 3a minus 5a. So if you think about 3 minus 5, we're going to be in negatives. So that's going to leave us with negative 2a. And then 4 plus 2, that leaves us with plus 6b. And that would be our final answer, because why? We cannot add the 2 and the 6 here because they are unlike terms. We can't add apples and bananas. So they are simply unlike terms. So that's how we simplify expression. And as I've said, we're taking this step by step. So we're going to add another layer to this now, where we're going to evaluate an expression. Now for this one, let's say we have 3x plus 4, and we're going to evaluate this when x is equal to 2. So here in this instance, we get a value 4x. So we're going to actually substitute a value 4x. And what you have to see this 3x as, you need to see it as 3 multiplied by whatever value x is. And in this case, of course, we get the value 4x. So what we will do, we'll just simply replace x with the 2. So we end up with 3 multiplied by 2 and plus 4. And of course, what we have to do first is the 3 times 2. This gives us 6 plus 4. So the value of this expression is 10. So once you get the idea here that 3x means 3 times the value of x, then we know that we're doing 3 times 2 and then plus 4. Now let's do another one. So for this one, let's say we have 2a minus b, and we're saying that a is equal to 5 and b is equal to 3. Now again, just like before, the value of a is 5, so we have to substitute 5 for a. And 2a means 2 times the value of a. So we will end up with 2 multiplied by the value of a, which is 5, it's right here, minus the value of b, which is over here again, so that's 3. And now we're just going to do 2 times 5 to get that value, which is 10. So we have right here 10, take away 3, so that final value is simply 7. And that's our final answer for the evaluation. Hope you're following so far, because if you are, then you are ahead of at least 20% of people with what you know so far. And all I'm asking you to do for this video, just give it a like, subscribe to the channel, and help me to reach as many people who will need this as possible. Help us to grow a community. So let's get into the next phase then. So this now is looking at something called distributive property. Now we apply this when we have, say, a bracket and a value outside of the bracket, and we need to basically expand this bracket. That's all this is really. So in this case, we are meant to multiply each of these elements inside the bracket by what's outside. So we're going to do 5 multiplied by x, and that will give us 5x. So 5 times x is 5x. And then we're going to do now 5 multiplied by this positive 2 here. So 5 times 2, and it's a positive 2, is going to give us 10. And that's it. That's how we apply this distributive property. So we just use whatever is outside of the bracket to multiply each term inside the bracket. So let's do another one, building on this as we go. So let's say we have 2 multiplied by 3x minus 4. So once again, we have to do 2 multiplied by 3x, and that gives us 6x. So 2 times 3 is 6, and because it's 3x, it's 2 times 3 lots of x's. So we have 6 lots of x's. And then we go for 2 times that negative 4 there. And now we have to be mindful of the minus. So we have 2 times 4 is 8, but 2 times negative 4 is negative 8. And that leaves us with our final answer, because remember, these are unlike terms, so we can't really add or subtract them. All right, brilliant. So if you're keeping up so far, you are absolutely smashing it, and you're proving the point that algebra is actually very, very simple. So we have here now in this one 4x minus 2x and plus 7. And before I do this one, all I need you to do is to identify what are the like terms. And if you guess the 4x and that minus 2x, then you are spot on. So all you have to do is to simplify this portion where we have 4x minus 2x, and that leaves us with 2x. And because we cannot add 2x with that 7, it's just going to leave us with 2x plus 7. And that's our final answer there. So well done if you got that one. If you didn't, we're going to do another one now, and it's the same process. So let's say we have 3a. Your objective here is to identify what the like terms are. And if you guess already that it's 3a and minus 2a, then well done. And we also have this plus 4b and minus b. So let's put the a's together now. So we will have 3a and that minus 2a. Remember, you have to look at the sign as well. And then with the b's, it's going to be plus 4b and minus b. And all we have to do here now is just to simplify our a's. So 3a minus 2a, that leaves us with just 1a, or you can simply write that as a. And this plus 4b minus b. So see this minus b as 1b. So what you actually have is 4 take away 1. And that leaves us with this plus 3b. And that's our final answer there, because we cannot add the a's and the b's together. All right, so one last practice example, and in this one we're going to combine everything that we did so far. So let's say we have 6 outside a bracket with 2x plus 3, and in addition we have minus 4x. What's our first step? Now, if you guess that we need to expand this bracket, then you are smashing it, because that's our first step. So we're going to do 6 multiplied by 2x. And 6 multiplied by 2x will give us 12x. And then we're going to multiply 6 again by 3, which leaves us with 18. And that's our bracket expanded. All we need to do now is to just put back that minus 4x right there, because it's not contained in the bracket. So therefore, we're not going to multiply 6 by that negative 4x. So what leaves now? We need to group this 12x with this minus 4x. And what that looks like? 12x minus 4x. And of course, that 18, we didn't do anything to it, so plus 18. So what's left? Simplify. 12x minus 4x, that leaves us with 8x. And we have 8x plus 18. Why? We cannot add 18 with that 8x. So that's where that bit stops. So again, well done. If you're smashing this with me, you're doing absolutely amazing. If you are enjoying this as well, then please give the video a thumbs up. I would like to have this video reach as many people as possible to finally get a grip of this algebra. So let's go now into another very, very important topic that tends to ruin algebra for so many people, and it's called order of operations. So now you probably seen this called PEMDAS, BODMAS, BIDMAS, all of those different terminologies. You've probably seen it so many times. I'm just going to use PEMDAS, and it really doesn't matter a lot, because the way I'm going to show you it now, you will see what I mean. So even though in this PEMDAS it's spelled out as M and D for multiplication, division, and A and S for addition, subtraction, and we have the P and the E, of course, for brackets or parentheses, and the E for exponent. It's really the same thing, but here is what really matters. So in terms of priority, you must do your brackets first, okay? So that's a must. And you must do whatever exponent you have as well. But as it relates to these two, they have equal priority, so you can do them in any order for that. And these two, and I'm going to show you why that works as well, and you will get so much clarity with how I'm going to show you it. So for this one, we have 3 plus 4 and times 2. So the priority here, first of all, is multiplication. So we need to resolve this. So just see all of this now as one value. So we'll get this as 3 plus that 4 times 2, which its value is 8. And we just have 8 plus 3 now. And that just leaves us with 11. Now, let's add. So we're going to keep the same number. So let's say we keep the same 3 plus 4 and times 2. But we're going to now add a bracket here. Now, that bracket, it changes the priority or the order in which we do this. So now we can't do the 4 times 2 first, because we have to work out this bit in the bracket first. So it now becomes 7 and times 2, which that gives us 14. Okay, so that's what the priorities or the orders represent. It just represents the order in which we need to work this out. And this is a very good acronym that you can use. So you go in order of the parentheses or the bracket, then our exponent, then we can do multiplication or division, these two, and we can do addition or subtraction. Right, so let's introduce some powers now along with multiplication. So let's say what we had was 2 plus 3 squared times 2. Again, you need to ensure that you see this now as a single value, because that's our first priority. That's the exponent, since we don't have any bracket. So this now becomes 2 plus 3 squared, that's 9, and times 2. And we go to the next priority, which is 2 times 9. So this now just leaves us with 2 and plus 18, which leaves us with 20. So that's it for this section, and we're going to step things up a little bit more, and we are going to look at another bit that you need to know. And remember, everything is building on top of each other, so if you just follow me step by step, then you will get a holistic understanding of algebra. And the next bit that we're going to look at now is part 2. So this is equations and what's known as linear relationship. Okay, that's linear relationship, bad writing there. So what is this really? This is basically us solving equations. And what we're going to do here, we're going to build this up step by step. So first of all, what's an equation? So let's say I'm not going to solve this one, so don't worry, I'm just going to use it to explain. So let's say we have 3x plus 2 equals 11. Now the equal sign, it tells us that both sides are balanced, and what we want to do, we want to find a value for x in this instance to make this equation true. So let's look at this, and as I said, we're going to build it up step by step now. So let's say what we have here is x plus 4 equals 9. Now, I know straight away, looking at this, you can tell me the answer, but we're going to be very systematic, and it's very good that already you can see that it's 5 plus 4 equals 9. But sometimes when you just look at it, tell the answer with these easy ones, it doesn't translate when it gets more complicated. So here's what I'm going to do here. I'm going to have you approach it like this. So just see it with this balancing approach. So what we actually did to get the 5 is to do the inverse operation of that plus 4, which is to take 4 like that. And 4 minus 4 right here leaves 0. So we get x equals 5. Trust me, this is going to make your life so much easier when you build it up like this. So just trust me on this. Remember, I'm proving to here that algebra is actually very simple. So let's say we have this here, x minus 7 equals 3. You already guessed it. We have take 7 there. So the inverse of that is to add 7. So what happens here is minus 7 plus 7 is actually 0. And this is you killing two birds with one stone. So you already know that that's 0 when we get to operations with integers. And what's happening now? X is actually equal to 10. And of course, you can check your working out, because if you replace x right there with 10, then 10 take 7 equals 3. Now, so we just did an addition, a subtraction. We're going to now do a multiplication. And that one's, we have been seeing that before. So let's say what we have here now is 3x equals 12. Of course, we have established that the operation here between the 3 and the x is actually multiplication. So the inverse of that is if we divide both sides by 3, then 3 will cancel 3, leaves us with x over there. That's just x equals 4. So that's done. Now, final one here. Let's say we have x divided by 5, and that equals 6. Once again, apply inverse operation. So the inverse of dividing by 5 is to multiply by 5, like that. And you will see where 5 will cancel 5. So what we have left is just x equals 30. And it should make sense, because if we do 30 divided by 5, then we get the answer that we started off with, which is 6. So that should make sense. All right, so if you are following along, you are absolutely smashing it. The only thing I ask you to do is to subscribe to the channel and leave a like. Now, another very, very, very top thing that I'd like you to do afterwards is also to just leave a comment as to what other series you'd like to see me do similar to this masterclass. So let's say we have 2x plus 5, and that equals 15. Now, again, what we need to do, we need to do the inverse operation. But this time around, because we have two things happening, we have a plus 5 and we also have a multiplied by x, or multiplied by 2. So what we have to do first is get rid of the plus 5. So we're going to do take 5. So what we have left here is just 2x, because 5 take 5 is 0, and 2x is going to be equal to 15 minus 5 is 10. So all we have left is just to divide both sides by 2. And you see how this is starting to look very, very straightforward when we just apply this systematic approach here. So what we have left then is just x equals 5. And once again, if you are getting this, I'm telling you, you are smashing it, and you just need to keep going, because it's just going to build on top of each other, every single thing that we do, and you will find that maths becomes so easy when you take that approach. Now, I'm going to throw in a negative here just to kind of try and rattle you a little bit. And you can pause the video and go ahead, try and solve it before I am. So step 1, similar to previously, that's plus 7. So we're going to do the inverse of that there, which is minus 7. So minus 7 there. And what we have left here is just negative 3x. And if we do negative 8 minus 7, that's going to leave us with negative 15. And don't worry if you don't understand how we get these bits yet, because I'm going to do a full series on that as well. So don't worry about it. So what we have left, we have minus 3x equals negative 15. So inverse of multiplying by negative 3 is to divide by negative 3, like that. So negative 3 will cancel negative 3. So what we have left is just x equals negative 15 divided by negative 3. So x is positive 5. And that's that one. Now I'm going to throw a curveball at you, and if you can manage to do this, then this is just proving my point that algebra is actually very simple. Now this one, I've seen so many students cry over these types of questions, and it's when we have unknown on both sides. What do we do? And the answer is actually way simpler than you think. And this is where my approach comes in, where we're just applying this balancing approach. So what you would do, if you haven't paused the video and tried it yet, we're going to just simply subtract from both sides the lowest value of x. And in this instance, it's 2x. So if we take 2x from both sides like that, then on this left side, we have 4x minus 2x, and that leaves us with just 2x minus 3, and 2x minus 2x on this right side will leave us with 0. So that just leaves us with 5 over here. And right away, this comes back to what we have been doing. Right away, this looks familiar. So this is what I mean when I say just build it up. Trust the process, because when we get to these types, it will make your lives so much easier. Just in one step, it is familiar territory. So what we have now, minus 3. So we're going to do the inverse of that. So plus 3 there and plus 3 there. And this is going, because that's just 0. So we just have 2x equals 8. And if you've been following, you will know that we're just going to divide by 2 now. So we just have, for our final answer, x equals 8 divided by 2, 4. So you see how straightforward this thing can be when we have everything just built up systematically. Alright, so we have two special cases of equations, and I'm just throwing this in for you to actually know that it exists, but very rarely you will see this. So one case is when there is actually no solution. Let me show you what that is. And it's not even an equation, it's just a true or false type statement. So let's say we had 2x plus 3 equals 2x minus 5. Of course, we would try to get the x's on both sides. So when we subtract 2x from both sides, then what we end up with here is a statement that is not true. We actually end up with 3, which is not equal to negative 5. So in this instance, this is what's classed as a no solution equation. And then another unique one, these two are just for fun. I'm just rewarding you with two lovely things to be aware of. You can even challenge your friends and see what they come up with. So this one is what's known as an infinite solution. And all this one is let's say we have 3 open bracket x minus 2 equals 3x minus 6. Now, the reason why this is actually infinite, and you might be thinking it's similar to the previous one, but it's not, is when we expand this, we end up with 3x. So remember, we did expansion, so 3 times x, 3x, and 3 times that negative 2, negative 6, equals 3x minus 6. So these two are actually, they are identities, so it's always true. So these two equations, they are actually identities. So it doesn't matter what values we substitute for x, both sides will always be true. Good. Now, if you are enjoying this, please just hit subscribe and like the video if you haven't done so already. So, inequalities and absolute values. Now, inequalities, you probably heard these before, and it's going to be very similar to what we have been doing with solving equations, except for one instance, which I'm going to get to that. But basically, it's just when we see these symbols. So that one is our greater than. This one is our lesser than. And if we see that plus that, it's greater than or equal to, and lesser than or equal to. So let's see what this looks like now. Let's say we have, for instance, x plus 3 is lesser than 7. So what this means is the value of x is going to have a range of values. So we are going to actually solve this exactly the same way that we did for solving equation. What that looks like is exactly the same process. So take 3 there. So x is actually going to be lesser than 7. Take 3, 4. So the range of values for x will start from 3. So 3, 2, 1, 0, keep going downwards. So that's an example there. And as you can see, it's actually the exact same process that we used when we were solving equations. Now let's look at another example here. So let's say we have this one here now. So I'm just going to throw in a 2-step. So let's say we have 2x minus 5 is greater than or equal to 9. Once again, the steps are exactly the same as what we did for solving equation. So we're taking 5, inverse, add 5, add 5. What we have left, just 2x greater than or equal to 9 plus 5, 14. So final step is to divide by 2. So then x must be greater than or equal to 7. So you see where this is exactly the same as solving equations. But I did mention that there was one unique case. And I'm just going to get to that now, since we already know that this is exactly the same as solving equations. So let's say we have negative 3x is lesser than is lesser than 6. Now in this instance, our steps look the same, but just be mindful that if we are multiplying, in this case, x by a negative number, after we divide our both sides by that same negative number, for our answer, we have to remember to reverse the sign. So this will now be greater than, okay? So it's greater than negative 2. So just remember that this is an exception where we reverse the symbol if the multiplier here is negative. That's the only exception. That's it. Nothing more. Okay? We're going to build on this now. So again, I've asked a few times, but just in case you haven't already, give the video a thumbs up, subscribe to the channel. I would really love to reach as many people as possible, because I'm pretty sure this will be quite useful to so many people you might know. So we're now looking at what's known as systems of equations, or some people will call it simultaneous equations. Same difference really, depending on the country that you're in. Now, all this is a setup of two or more equations with the same variables, and we basically need to solve for whatever the variables are. So let's say in this instance we have y equals 3x minus 2, and we have x plus y equals 16, and we need to solve these two. Now, yes, I know it looks as if it's complicated and all that, but as I've said to you before, algebra is actually very simple, and I'm going to prove that to you with this one here now. Just before I go to this solution for this one, it's very important to know that we have multiple ways to solve these. One of them is by graphing, and the method I'm going to use now in this one is called substitution. So I'm using the substitution method for this one. And all that is, in this instance, you can see where in one of our equation we have y on one side by itself. So that's that equation. So it's telling us that the value of y is 3x minus 2. Now, all we're going to do is to replace y in this second equation down here with that same value, 3x minus 2. And what that looks like now is this. So we have x plus, and I'm now going to replace the y with what's up top, this bit here, that 3x. So I'll just put it in brackets so you can see that's what I'm doing. So I've just replaced y with the 3x minus 2 that is coming from up top that says y equals 3x minus 2. And this now allows me to solve this equation with just x's. And we have done this before. So what we actually end up with is a simple equation just like the ones that we solved before. So this now will look like this. So we'll have x plus 3x minus 2 equals 16. X plus 3x, we know how to simplify this. So that's just going to give us 4x minus 2 equals 16. And this is back to the good old solving two steps equation. So we're just going to add 2 there to get rid of that, and we have 4x equals 18. So since 4x is equal to 18, of course it's absolutely fine to get a decimal. We're just going to divide by 4 here, and x 4 goes into 4 once, leave us with x, and x now is by itself. So we have 18 divided by 4, which is just simply 4.5 for the value of x. And what we're going to do with that value for x now is we're going to put that into the very first equation that we started off with, which is this one at the very top right here. This one right here at the very top that says y equals 3x minus 2. So we're going to solve for y now. So we have y equals 3x minus 2, and we know the value of x, it's 4.5. So we're just going to replace x with 4.5. And now again, we're just applying one of the concepts that we did previously, where we evaluated expressions, where we substituted that values for, in this case, it's substituting value for x. And when we work this bit out, we're going to end up doing 3 times 4.5 and minus 2. That will leave us with 11.5. So we get the value for x and we get the value for y. And that's basically how you use the substitution method. It's pretty straightforward in this case here. So let's look at another method to solve simultaneous equation, and this method is known as the elimination method. Remember, we have several methods. These are just a few. We have using matrices, but don't worry about that. We're just focusing on what's in front of us now. So we have this setup. So let's say we have these two equations, and what we're going to do is we're going to apply the elimination method. And for the elimination method, if it is that we have In this case, two variables being the same, so we have that plus 3y and we have that next minus 3y. Then to get rid of those two, we will simply just add the equations together. And what that will look like, we can literally just draw a line here and just add these two like that. So we'll end up with 2x plus 4x. That leaves us with 6x. And then when we do that 3y plus minus 3y, that's actually 0. So we have eliminated the y's now, which is why it's called the elimination method. And then we end up with 12 plus 6 there, which is 18. So right away, we end up with a one-step solution for this equation. So we just divide by 6, and we end up with x equals 3. And just like we did before, we get the value for x. All we have to do then is just to substitute it into one of the equations. And we can choose any one. We can either choose the 2x plus 3y, or we can choose the 4x. It really doesn't matter which one we choose. Let's just use 2x plus 3y equals 12. So we have 2x plus 3y equals 12. And we're going to substitute this 3 that we just found for x in this equation down here. So we're going to replace x now with 3. And what we're left with is just one unknown, which is the y. And that's what we're going to solve for. So 2 times 3 there, that's 6 plus 3y equals 12. So when we take 6, we end up with just 3y equals 12 minus 6 there, that's 6. So therefore, y is equal to 6 divided by 3. So y is equal to 2. So we get the value of x and we get the value of y here in this instance. So you can see that these are pretty straightforward stuff. And if you've ever felt intimidated by algebra, then you have no reason to fear, because we're smashing this. And if you're following so far, then honestly, you are going to do absolutely amazing in this. And we're pretty much halfway there, I would say. We're going to look at another bit that tend to challenge students somewhat. And again, if we follow these simple rules and the systems I'm showing you, you will be absolutely fine. This one is called exponents. So it's exponents and scientific notations. And this is basically the same as what you will see as laws of indices in this instance. So it's nothing new. We're just going to ensure that we understand what it is, what it does, and look at a few. So let's start off then with the laws. So the first one is the product. Now, for the product rule, let's say we have a to the power of m times a to the power of n. Then for this rule, what that will be is just a to the power of m plus n. So we will, of course, replace the a's and the m's and the n's with numbers. And we'll see how this works in terms of algebra. So let's say what we have was, for instance, x to the power of 3 being multiplied by x to the power of 5. What we need to do to solve this, basically following the rule up top, we're just simply going to keep the bases. So the base is x in this case, so just keep the base and add these powers here. So we end up with 3 plus 5 there. So our final answer is x to the power of 8. And that's how we apply that rule. So that's the product rule. Now, the next one is when we're dividing, and that one is the quotient. So that's a quotient rule. And it's kind of similar. So let's say we have a to the power of m divided by a to the power of n. All we have to do here in this instance is to subtract the powers. So let's say we do another example similar to the previous. So let's say we have now x to the power of 7 and divided by x to the power of 2. We're just going to subtract these two powers. So it's just 7 minus 2. And of course, we keep the base. So the x in this case, it's the base. So we keep that, subtract the powers. So we're left with x to the power of 5. Brilliant. So let's look at another rule, and this one is known as the power rule. So that's the power rule. Now, let's say in this instance, what we have is a to the power of m, and in bracket to another power like that. Then all we do with the powers when we have this format is just multiply them, and that's it. So let's do it again just like we've been doing. So say we have x to the power of 4 in bracket and raised to another power. Straightforward, you guessed it. So it's x to the power of 4 multiplied by 2, and this one is 8. So many students tend to make mistakes with this one, and they tend to just add the power for the power rule, but it's multiplying. Now, let's say we have some sort of negative powers. So this one is negative powers. So this one is pretty straightforward. Again, let's say it's a to the power of negative n. Then we just write that same thing with 1 over a to the power of now positive n. And that's it. That's all there is to this one. So I'm going to use some numbers for this one actually. So let's say it's just 2 to the power of negative 4. To work that out, we just do 1 over 2 to the power of 4. And 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So that one would be done. It's as straightforward as that. Now, you might be asking, what if, let's say you're asking, what if we have, say, x to the power of negative 2, and we're multiplying that by x to the power of 3. Now, you have options to choose from, but the easiest option is just stick to what we did in the beginning, where we added these two powers, like so. And when we add these two, it's negative 2 plus 3. So that's just going to leave us with 1. And that's that. And one more law that we need to be very, very mindful of is any value, any non-zero value that's raised to the power of 0, the answer is always going to be 1. So if we have, let's say, 1,000,000 or however many zeros you want to add raised to the power of 0, this is going to be 1. And we have justifications for it. So let me just show that to you now. So let's say we have 2 to the power of 3 divided by 2 to the power of 3. Of course, we can do this by subtracting the powers, but we are going to left with 2 to the power of 0, which is 1. But what I'm going to do is to prove to you why this is actually 1. So 2 to the power of 3 is the same as 2 times 2 times 2. And it's being divided by 2 to the power of 3. So if we put that as the same 2 times 2 times 2, then this value at the top is going to be 8 divided by 8, which is the same as 1. So any value raised to the power of 0, it's going to be 1. All right, so let's look at when we have some fractional index now, or fractional indices. So let's say we have x to the power of 1/2. All we have to do is find the square root of x in this case. So if it was something like, say, 25 to the power of 1/2, it's just the square root of 25 we want to find there, which is just to think of what number you multiplied by itself to give you 25. And that number, it's 5. Why is it 5, you might ask? It's simply because if we do 5 times 5, we get 25. Technically, we can put plus or a minus 5, because if we were to do negative 5 times negative 5, we would still get a positive 25. So it's basically any number we multiply by itself to give whatever is under the square root there. And in this case, it's 5, or plus or minus 5. So we have this next one here, which is, it's kind of a spin-off to that previous. where let's say we have x to the power of n over m. That will just look something like so. So the n will go like this. So x to the power of m goes there and n goes there. Just needed to ensure that that's quite fine. So let's put that in practice. Let's say we have 8 to the power of 2 over 3. Now we have a few ways to actually write this one, and I'm going to show you a second way in which we can write it. We can do like this, so the cube will come there like I've showed you up top, and we can then put outside this bracket the square like that. So 8 cubed, which is the same as having 2, and then we just square it to get 4. Okay, so this 8 cubed, it's actually 2. Why? Because if we were to do 2 times 2 times 2, then it's the same as having 2 2's 4, 4 2's 8. So when we do the cube root of 8, it's that number where when we multiply it by itself like this, then we get that very same 8 right there. So that's why in this instance, the cube root of 8 is 2. We have this next one here called polynomials. And a polynomial is simply an expression that is made of terms with variables raised to whole number powers. So let me show you what that looks like now. So if we have, say, 3x squared plus 2x and minus 7, that's an example of a polynomial. If we have, let's say, x to the power of negative 2 plus 4, in this instance, that's not an example because we don't want to use any negative exponents in our polynomials. So that's an example up top. Let's do another non-example. We know we have, let's say, x to the power of a half or something like that plus 1. Again, that's not a polynomial. Why? Because we need to have just whole number powers that are positive. And these will be grouped as terms. And again, I've talked to you about what a term is. Let's say we have once more 3x squared minus 7. So in this instance, we have two terms because terms can only be separated with a plus or a minus. So that 7 or negative 7 there, that's what we class as a constant term. And then we have that next term, which is 3x squared. That's our variable term. Now we're going to look at how we classify polynomials. And polynomials, they're classified. So get this part here. This is actually very, very fun. So let me even add this heading to it. So we're classifying polynomials. Okay. So let me show you what that looks like now. So if we have one term, then believe it or not, there's something called a monomial. I don't know if I've said that correctly. So that's an example. So 6x. Let's say we have two terms within our expression. So it could be something like x squared minus 9, something like that, for instance. Then this one is what's known as a binomial. Let's say we have three terms. I'm waiting on you to guess this one. So it could be something like, let's say, x squared plus 4x plus 3. Then this is what's known as a trinomial. Okay. Pretty straightforward stuff. Now we can describe these using the powers as well, and that's where this bit gets a little bit not tricky, because you'll get it. Like I said, it's just simple stuff. I'll prove it to you now. We're going to describe these by degrees, and I'll show you what by degrees mean. So let's say we have to 1 degree or to degree 1. Don't worry, I'm going to show you what degree is now. So this is going to be something like this, 2x plus 1. What degree is, it's just going to represent the highest power of x. And in this case, 2x is the same as having 2x to the power of 1. So whenever the highest power of x is 1, then this is what's known as linear. And that's all it is. Nothing. I told you this stuff is really straightforward. Let's say it's going to be having degree of 2. Now you have seen ones like this and you have seen the topics, but hopefully you know why it's called what it's called. So if the degree is 2, so meaning the highest power of x is 2, this is what we call a quadratic. Hence, you have quadratic equations, quadratic expressions, and so forth. And I'm going to do one more. Let's say we have degree of 3. Then you could see something like this, for instance. And it doesn't matter how many terms, we're just looking now at the highest power. This one is what's known as cubic. So if the highest power is 1, then it's linear. If the highest power of x is 2, it's quadratic. If the highest power of x is 3, it's cubic. And if we're thinking of how many terms like these, then if it's only one term, it's monomial. If it's 2 terms, binomial. 3 terms, trinomial. That's all it is. And I'm sure you get this. All right, so what we're going to do with them now, we're going to add another degree of complexity, but we know that it's simple stuff really. So we're just going to simply add and subtract polynomials. You will find this very, very, very enjoyable. We're just going to add and subtract some polynomials now. And it's just the same as what we have done before. And I'm going to once again prove to you that algebra is actually very simple. So look at this now. Let's say we have 3x squared plus 2x minus 5. And I'm going to try my very best to make this even as complex as I can make it, because you are getting this and this is going to be easy stuff for you. So this is as complex as I can make it. The screen is entirely full. Show you that this is straightforward stuff. So we're adding these polynomials now. So we have 3x squared plus 2x minus 5 plus we have 4x squared minus 6x and plus 1. Now all we're going to do here is just simplify this thing. So we're going to add these two together, the 3x squared with the 4x squared. In fact, I'm just going to group them up now. So we have 3x squared plus 4x squared. Both of them are positive. We have this plus 2x and this minus 6x. So I'm just going to do it exactly as I've said it. It's plus 2x and minus 6x. Okay? And then now we have this minus 5 and plus 1. Once again, exactly as I've said it. Minus 5 plus 1. So we just have 3 things to simplify now. 3 lots of x squared plus 4 lots of x squared is 7 lots of x squared. We're only adding the coefficients, the 4 and the 3. Then we have 2 minus 6. So I'm talking about that plus 2 minus 6. So that's just going to leave us with negative 4x right there. And don't worry if you don't get the 2 minus 6 being negative 4, because I'm going to do a full series on that. And finally, we have negative 5 plus 1, and that's just minus 4. And we are done. That's simplified because these are now all unlike terms. See, I told you would get this. Algebra is actually very simple. You got this. Now, again, if you haven't done so already, I know I've asked you before, but I just want to remind you, and especially for people who have jumped to this section of the video, just give it a like, give it a subscribe to the channel, because I'm trying to reach as many people as possible to prove that algebra is actually very simple. So let's look at another example similar to the previous one. So we have 6a squared. I'm gonna bracket it minus 3a plus 2. I'm putting a minus this time. Minus 2a squared plus 5a minus 1. Now I'm going to show you a trick with this one. It's not really a trick, but it's something that is quite useful. So like this minus, it can tend to throw a lot of people off. So what we can do with that is, if we were to rewrite this like so, so just put everything that's in the first bracket as is, and if you were to change this minus sign to a plus, and then now inside this bracket, instead of having a 2a squared, change it to a negative 2a squared. Just reverse all these symbols. Reverse this 5a to a minus 5a, and reverse that negative 1 to a plus 1. And then now when we group, we're literally just going to group what's in the bracket as is. Show you what that looks like. So we have that 6a squared and we have that minus 2a squared. So put them together exactly as you have said it. 6a squared minus 2a squared. Get some space there. Then now we have this minus 3a squared with that minus 5a. So minus 3a minus 5a. And then that plus 2 plus 1. So plus 2 plus 1. And just simplify it. So 6a squared minus 2a squared. It's just 6 minus 2 we're doing there. So 4a squared we have there. And we're increasing in negative. So negative 3 there, minus 5. So that's just negative 8a. And 2 plus 1 plus 3. And that's done right there. So 4a squared minus 8a and plus 3. So that's that. So hopefully you get, I'm not even saying hopefully, I know that you are smashing this. And what we're going to look at next is how to multiply. Right, so let's say what we have in one bracket is x plus 2. And in another bracket is x plus 5. This is going to turn out to be pretty straightforward to you. Some people like to use a method called FOIL, but all I'm going to show you is we're going to take that first term and write it outside of that bracket like so, x plus 5. And then we're going to take this second term right there and write it outside of the very same bracket here like so. And then we just expand the bracket. This is how we do that. X times x and then x times 5. So x times x, that's x squared. X times 5, that's plus 5x. 2 times x, that's just 2x. And 2 times 5, that's just 10. And by now, you would have noticed we can simplify right there in the middle. So what we end up with is just x squared, 5 plus 2, plus 7x, plus 10. And that's done. That's it. Done. So because that one was so much fun, I'm going to do another one, but just add another level of complexity. So let's say instead of having x, we have now 2x, minus this time instead of plus, minus 3x, and that multiplied by x minus 4. Do the same thing. I'm going to put that 2x outside of all of that bracket, so x minus 4 goes there. And I'm going to put that minus 3 outside of, you guessed it, all of that same bracket. So let's do 2x times x. So that's going to be 2x squared. 2x times negative 4, that's negative 8x. Let's go to the 3 now. So 3 multiplied by x right there. So that's just negative 3x. And negative 3 times negative 4, that's a positive 12. And just like before, we have this bit in the middle to simplify. So we end up with 2x squared minus 11x and plus 12. And that's done. Pretty straightforward. Now I'm going to give you some almost like cheat sheets here to basically expand these brackets. And there are some special cases that you can just go to the answer right away. And one of those special cases is when we have something called a perfect square binomial. And what that is let's say we have a plus b all squared. Then this is just having this here, a squared plus 2 times ab plus b squared. So as you can imagine, if let's say this was x plus 4 and all squared, then we don't even have to expand this out. We can just simply write this as x squared plus, we say 2 times ab, so that's ab, so it's gonna be 2 multiplied by x multiplied by 4, so that gives us 8x there, and plus b is where the 4 is, so that's just going to be 4 squared, which is 16, and that's done. We have another version of that when it's negative. So let's say we have a minus b and all squared. Then in this instance, we can just write it similar. So it's a squared minus 2ab plus b squared. So it's pretty similar stuff. Only difference is right there in the middle where we have that ab, it's negative, but it's literally the same thing. We have this other instance where it's called a difference of two squares. Pretty straightforward one this is, and it's, let's say we have a squared minus b squared. Then when we factor, when we're expanding this, it's just going to give us a plus b in one bracket and a minus b in another bracket. So it can go two ways really. Let's say for instance we have, I'll just use x plus 4 times x minus 4. Then the final answer for this is no doubt going to turn out to be x squared minus 16. And you can go ahead and expand this bracket, but all I've done was just to apply that rule right here up top to solve. So use those, they are very, very, very good. And this is now dividing. Now out of all of them, this is probably one of my favorite, I'm not gonna lie. And I don't know if it is because this is something that people struggle with and I just tend to get it. I don't know. So let me ensure that you get it. So let's say we have 6x cubed minus 9x squared plus 12x, and all of that is divided by 3x. You will see where it's pretty straightforward here, because what we're going to end up doing is just do 3x into each of these. So let's say 3x into 6x cubed. Just do 3 into 6 first. That's just 2. And if we divide x cubed by x, let me put that one side for you. When we do x cubed divided by x, just think of x to the power of 1. It's the same as us just subtracting 1 off each of these powers. So that's just going to be x squared. So whenever we're dividing through, in this instance, by x, we're just going to take away 1 from each of the powers, basically. That's how you can interpret it. So this will leave us with 2x squared right there. And then 3 into 9, that's 3. Remember what I said, we're just subtracting 1 from the power there. So that just leaves us with 3x. Then 3 into 12, that's just 4. But when we subtract 1 off this power, it's 0. So we're just left with 4 right there. And that's it. That one is all done. Like, all done. Now, we have other methods to do this. We have long division methods and stuff like that, but we're going to leave that bit for now, because what we're going to go into is what comes naturally next, which is to factorize. Okay. Now, again, if you have not already subscribed and you're here until this point, or if you're just joining, then please subscribe to the channel, give the video a thumbs up, help us to reach as many people as possible. All right, so let's factorize. So for this one, let's say we have 12x squared plus 18x. When we're factorizing, all we're looking for is the highest common factor. So what's the highest value that can go into 12 and 18? Think about it. Is it 2? Is it 3? Is it 6? Of course, you guessed it. It's 6. And then when we're looking at the x's, this one is quite simple, because if x is common to both of these terms, so what that means is we have an x squared there, we have an x there, we're just going to use the x with the lowest power. So we combine 6 with x. So that's now our highest common factor. And what we'll do, we'll now open up a bracket and divide through each of these by 6x. So just do 6 into 12, that's just 2. And remember what I said, when we're dividing through now by x, in this instance, we're just literally going to take away 1 off the power. So that just leaves us with 2x. 6 into 18, that's 3, and x will cancel itself. So that's all we have left. And you can check your answers, because if you were to do 6x times 2x, 6 times 2, 12x times x, x squared. 6x times 6x times 3, 18x. So there you go. You can actually check your answers. So let's get a little bit more decorative. And again, you will see that it's simple because you're getting it. So we have 8a to the power of 3 and b squared minus 4a squared and b. Of course, you might be thinking this looks a little bit challenging, but remember, algebra is actually very simple. So start by looking at the 4 and the 8. What's common? What's the highest number that can go into both of these? It's 4. And because we have AB common to both of these, then AB is going to be a part of our factor there. Now, what we need to do now, we need to look at the A and the B and just use the one with the lowest power. So A squared is the lowest power there for the A, and for the B, it's just B. So that's our highest common factor. And let's just divide through now. So 4 will go into 8 2 times, and A squared into A cubed. We're now taking 2 off this 3, so that leaves us with just A. B goes into B squared. We're now taking 1 off that 2, so that leaves us with just B. So what you need to ensure that you do with this one is for the powers, let me just put 1 there and 1 there. When you add this 2 for the A squared to this 1, so that 1 and this 2, they should give you back that 3 up top. When you add this 1 with this 1 for that B, they should give you back this 2 up top. So you can use that to check as you go. So 4 will cancel 4, so that's just 1. A square will cancel A squared. B will cancel B. So you notice that this is the exact term as that right there. So then it's just going to be 1 there. So this is our final answer. As is, it's just simply, let me just write that better, 4a squared b. And we have 2ab minus 1. That's it. That's done. Let's look at another form of factorizing, and this is called factorizing by grouping. So this is the grouping method. It's actually quite straightforward. So let's say we have x cubed. I'm going to prove it that it's simple. Just stick with it. You will see it's simple. And we have 3x plus 6 there. So all we have to do here is group the first 2, the last 2. and then we're just going to factorize. So highest factor for x cubed and 2x squared, it's just going to be x squared. The lowest power for x is what we're using. Then we divide through here, x cubed, we're going to take 2 off, so that leaves just x, plus x squared into x squared, that just leaves us with 2. And remember, you can always expand to check if you get the same thing. Then when we come over here now, we're just going to have 3 there, 3 into 3x, that's just x, 3 into 6, that's 2. And what we do now to get our final answer, what's outside this bracket and this one, we're going to contain them in one bracket. So we're going to just have x squared plus 3 in one bracket. And you notice that it's the same thing in this bracket and this one. And all we're going to do is just rewrite that once. And this here is our final answer. There you go. Now we are going to factorize some quadratics now. So factorizing quadratics. Now let's start with a simple one. Let's say we have x squared plus 7x and plus 12. Now in this instance we have the coefficient of the x squared as 1. If you don't see any value here, it means that the coefficient is 1. So this is the same as having 1x squared plus 7x plus 12. And how we do this, I'm going to give you a simple format that will work every time. So what we're going to do is see this as a for the 1, x squared, plus for the 7, b, x, and plus c. And every time we're just going to replace the a, the b, and the c with numbers. And for now, what we need to do is just think of any two numbers that when we multiply them, we get the constant term, in this instance 12. So we're thinking of two numbers that when we multiply them, we get a product of 12. And also when we add them, we get a sum of 7. So if you think of 3 times 4, that will give us 12. And 3 plus 4, that will give us 7. So what we do with those two numbers, we're going to use them in brackets. So our answer for this one is just going to be x plus 3 times x plus 4. And that's it. It's done. So all you do, I'm going to give you another one and you will see that it's pretty straightforward. Because all you're doing is just thinking of two numbers that when you multiply them, you get that 12. But when you add those two numbers, you get 7. And you can actually make up a question and you will see that it works every time. So I'm going to make up one now on the spot. So let's say we have x squared plus 8x plus 15. As I've written that, I was actually thinking of the two numbers. So I'm just thinking of two numbers that when I multiply them, I get 15, but when I add them, I get 8. So if you think of 5 times 3, that's 15. And if we do 5 plus 3, that's 8. So the answer to this one would just simply be x plus 5 times x plus 3. And that's it. That one solved. All done. All right, so of course they can be negative as well, and it will be the same gist that you follow. So let's say we have x squared minus 2x minus 15. Think of two numbers. When you multiply them, you get negative 15, but when you add them, you get negative 2. Those two numbers. So if we do negative 5 multiplied by 3, we get negative 15. And if we do negative 5 plus 3, we get negative 2. So what we do with that, they are our answers. It's just x minus 5 and x plus 3. And that's all done. And dusted as well. Let me just remind you of this format. So it's ax squared plus bx and plus c. And remember that a, b, and c, we're going to replace them with some values. Now, let's say in this instance, the value of a is not 1. So we have, let's say, 2x squared plus 7x and plus 3. What do we do in this instance? It's going to be quite straightforward. So all we have to do now to find out what our product is meant to be, we need to just first of all multiply the a value and the b value. So now we need two numbers that when we multiply them, they give us 6. So why 6? Because 2 times 3. So we just multiply the a value and the b value in this instance. So two numbers now that when we multiply them, we get 6. So, and when we add them, we get 7. So of course, if we do 6 times 1, we do get 6. And when we sum them, they actually give us 7. So it's going to be 6 and 1. Now, what we do with these two numbers will be slightly different to what we did with the previous. So what we're going to actually do is to replace the 7x with the 6 and the 1x. So this is what that looks like. So it's going to be 2x squared. So now I'm going to replace the 7x. So plus 6x and plus x. Why 6x and x? Because 6 is one of our number and 1 is one of our number. So 6x plus 1x and then plus the 3 at the end. And this now is going to come right back to what we just did, where we're just going to factorize the first two and the last two. So let's factorize 2x squared plus 6. So highest value into 2 and 6, that's 2. Highest value into x squared and x, that's just x. So that's our factor there. 2x into 2x squared, we're just left with x. 2x into 6x, we're going to be left with just plus 3 there. And we're now going to factorize the last two. So it's x plus 3. So there's only 1 that can go into both of those. And they'll just appear back in the bracket because 1 into x, x, 1 into 3, 3. And what we do, same as we did before, this 2x and that plus 1 is going to form one bracket. So 2x plus 1. And this x plus 3 that's repeated, it's just going to come back like that. And that is done. Pretty straightforward. Now, obviously, it will take you some more practice, but the fact of the matter is, once you get the idea, you get it. And that's all you need, the idea. What to do, that's all. So, I'm going to touch on solving the actual quadratic equation now. So what we just did was just factorizing. So I'm just going to show you how to solve them in 1 or 2 examples, and you will see that it's pretty straightforward again. So let's say we have now x squared plus 5x and plus 6 equals 0. Notice this time we have the equals 0, and that's what changes this equation, the expression, into an equation, just having equals 0. But the way we solve it now, the way we factorize, remain the same. So we need two numbers that when we multiply, we get 6. And when we add the same two numbers, we get 5. So those two numbers, 2 times 3 will give us 6, and 2 plus 3 will give us 5. So what we do here, we're just going to put in bracket x plus 2 times by x plus 3 equals 0. And what we're going to say here is either one of these brackets, in order for you to multiply two things and get 0, one of them must be 0. So we're going to say either x plus 2 is equal to 0 or x plus 3 equals 0. So one of them equals 0. So therefore, for this one up top, x plus 2 equals 0, the value of x would be equal to, that's negative 2. And for x plus 3 equals 0, the value of x would be equal to negative 3. So what that means is if we were to replace negative 2 in this bracket here, then that would turn out to be 0 times this bracket, which gives 0. And if we were to replace x with negative 3 in this next bracket here, purple arrow, Then negative 3 plus 3, 0. And 0 times whatever is here, still 0. So that's the logic behind this here. So we'll have two solutions for quadratic equations. That's that. It would be the very, very same thing we would apply to any other one of them. We will get either or, and we get two answers. Let me show you one more. Let's say we have x squared equals 49. Remember, highest power of x here is 2, so it would be a quadratic. And what we do is just simply inverse of x squared, so square root 49, and this is where the two solutions come in again, so it would be a plus 7 or a minus 7 for our answer. So that's the idea there. Now we have some other fun methods to solve quadratic equations, and I can't continue without doing this one. It's called completing the square. And we also have the formula. I'm not sure if we need to really do that one, but let me just show you this one here, which is solving quadratic equations by completing the square. And of course, whatever we do here for quadratic equation, we could have done it for quadratic expression as well. It's the same method that would apply. So let's say we are going to factorize this now, or we're going to solve this now by completing the square. What we would do first is we would first move the constant to the right hand side, so we'd just be subtracting 5 like that, so we have just the x's here, so we end up with x squared plus 6x equals negative 5. So that's step 1. Step 1 is to get the constant on the right hand side. Now step 2 is kind of 2 steps. We're going to half this term, let me use white, we're going to half that 6 there and square it. So that's the two things that I was saying. So half of 6 is 3, and 3 squared is 9. So this 9, we're going to add it to both sides. So what we end up with now is x squared plus 6x plus 9 equals negative 5 plus 9. And the reason why this works is because when we add 9 to both sides, it doesn't change the value of our expression. And what we actually end up with here is what's known as a perfect square. And how we solve this is we're just going to have x plus square root of 9 here is 3. And that's basically solved because it's a perfect square. And we square that bracket. And of course, over here, negative 5 plus 9 is equal to 4. So what we do now is just to solve this. So because that bracket is squared, we're going to do the inverse of squaring the bracket, which is to do square root. So we end up with x plus 3 equals the square root of 4. And this is where the plus or minus bit will come in now. So we have x plus 3 equals plus or minus square root 4, 2. So then we'll have two values. So we can say either x is equal to, we take positive 2 this instance, so 2 minus 3, or in this next instance we can say x is equal to negative 2 and minus 3 again. So for this one it's negative 1, and for this one it's negative 5. So where the two equations come from is because we have this plus or minus 2 here. And in one instance we used plus, and in another instance we use minus. So that's all it is really. So our two solutions, negative 1 and negative 5. So that's a completing the squares method. And once again, algebra is actually very simple. Now, we could look into solving quadratic equations using the formula. And of course, it's a valid one to actually look at. I'll share the formula with you and probably solve one. So this is the formula. It's x squared equals minus b plus or minus the square root of b squared minus 4ac and all divided by 2a. That's the quadratic formula. And all it is, if we were to get, say, some quadratic equations, let's say 2x squared minus 4x minus 6 equals 0, it's just us going to allocate the very same format. So minus ax plus bx plus c. So in this instance, our a value is going to be 2, our b value negative 4, and our c value is going to be negative 6. And we'll just substitute them in the formula there. And because it's pretty much you putting those in your calculator, I'm not going to go through that one. So that's going to be it for the quadratic equations. So I'm pretty sure this is resonating with you, and if you haven't done so already, or if you're just joining, then please hit subscribe and give the video a nice thumbs up so we can reach a lot more people, of course. So this one is quite nice. I'm going to go into another version of algebra that tends to elude some people, but not you, because you are following step by step. So we're going to do here what's called simplifying rational expressions. And all this is, it's just going to be what we just did, slightly compounded. So let me show you an example, and you will see that it's actually quite simple when you get what we just did. So let's say we have x squared minus 9 and all over x squared minus x minus 6. Now, just treat this as you would if you were to do fractions. So the x squared minus 9, remember when we looked at difference of two squares, this is going to be x minus 3 in one bracket and x plus 3 in another. And then underneath that now, if you think of two numbers that will multiply to give us negative 6 and add to give us negative 1. So that's the product, negative 6, and the sum, negative 1. And those two numbers are negative 3 and 2. So when we factorize that, we end up getting x minus 3 and x plus 2. And all you have to do here is cancel out the x minus 3's, and what you're left with is just x plus 3 over x plus 2. And that would be finished. That would be simplified. Now let me ask you for your input, because what I'm doing next, I'm going to work on a similar series for calculus, and I'll be looking at differentiation, I'll be looking at integration. And what I would really love is if you were to leave in the comment what other topics you would like me to look at, like holistically, just like this one, to create something like a full course. So just leave your answer in the comment and let me know, and I will definitely work on that based on popularity. So that's it. I will see you in the next one. Remember, subscribe and give the video a thumbs up.